Very good morning, students. So, welcome to IIT NEET Foundation, our Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So, once again, I welcome all the class 7th students for today's session. As you all can see on the screen, and you are well aware, my subject is physics. We are in class 7th. Our ongoing chapter, work, energy, and power. And today we are entering into the session number 3. So far we completed 2 sessions where we discussed about what is work, what are the types of works, right? Then we entered into energy and forms of energies. Various forms of energies we discussed in the last class. So today we are almost going to complete the conceptual part, that is about power, and which is this total chapter is the syllabus for our test number 6, which is on 30th December. So we are going to complete this chapter by today, or maybe hardly one more session, so that you can prepare well for the examination throughout the other days. So when you meet in the next class, we'll start the new chapter, that is the 7th chapter, circular motion. One kind of motion only, there is a various examples also there. But right now we have to focus on the today's class, where we are going to discuss about the remaining part of energy, where we left, and followed by power. What is power, right? But before that, let us recall what we covered so far in the last 2 sessions to understand the concept of work and energy. Okay, so you can see on a single picture what we learned. You can see the points also given as well as the pictures also. We learn about the work and we learn about the various forms of energies, right? So we started to learn about what is work. When you said work is done, so when a body displaces on application of force, the body displaces is very important. Okay, then unit of work, joule and erg. Mathematical expression of work, that is W is equal to F into S. Types of works, positive work, negative work, and zero work. Then we enter the word and energy. Energy is also nothing but work only, but capacity. Capacity or tendency of doing work is called energy, right? Then there are so many forms and so many types of energies are there. You can see on the screen also one picture: kinetic energy, potential energy, sound energy, mechanical energy, elastic energy, radiant energy, chemical energy, electric energy, nuclear energy, heat energy, and what else? So many energies are in our use. We are using them in one or other areas of our life, parts of our life. So that we discussed about the various forms of energies, what they are doing, how they are applicable for in our day-to-day life, and why they are called as energies. Because all these are having the capacity to do work. That's why they are placed under energy. So study about energy is the one most important part of the physics. Okay, so that is about energy. And also, before closing the session yesterday, I introduced the law of conservation of energy. So today we are going to cover about what is law of conservation of energy. We'll see a few examples for that. That is proof for the law of conservation of energy in different cases. Then finally conclude with the power. Okay, so as per the law of conservation of energy, the statement is energy is neither be created nor destroyed. Neither you can create the energy nor you can destroy energy. But what happens? Energy is converting from one form to another form, which is called transformation of energy. Energy transforms to other form. That's all. There is no wastage of energy. There is no creation of energy, right? That we'll discuss in this class. So before that, have a glance into the entire things what we learned in the last 2 sessions about the work, definition of work, unit of work, types of works. Okay. Then we enter into the second synopsis, energy, introduction to energy, definition of energy, unit of energy, which is the same as work. Okay. Then gravitational energy, potential energy, kinetic energy. So many types of energies we have seen. Now we have seen the different with this also. Formula for the kinetic energy, half mv square, 1 by 2 mv square, and formula for the gravitational potential energy, mgh. Okay, that is mathematical formulas. After that, now we have to enter into the statement here. That is what we discuss is law of conservation of energy. Total energy in system remains constant. Total energy in a system remains constant because energy can be neither created nor destroyed. That is a statement of law of conservation of energy. Right. So this is applicable not only for the various energy forms, it is also applicable in some special cases like a freely falling body. So 3 cases we have discussed here. Proof. One is freely falling body, right? Second one is vertically projected body, means thrown up, vertically projected body. And third one is pendulum. Pendulum case. 3 cases you have to prove. Proof is not required for you. Just understand the concept there, right? Freely falling body means suppose you are dropping a pen. So it is at a height of some height from the ground. So here the body, when you are at rest in your hands, it passes the potential energy mgh. There is no kinetic energy because the body is not moving, no velocity. So when you drop it, so potential energy is converting into kinetic, and finally touches the ground. So what we have to prove? We consider at any point in this path, the total energy remains constant. So what is total energy? So total energy is nothing but kinetic energy plus potential energy. That is, it should be equal to half mv square plus mgh. So simply you have to remember, either it is a vertical, the freely falling body, at each point of it, we can have total energy remains constant. Maybe at highest point, potential energy is maximum, kinetic energy is 0. At lowest point, kinetic energy is maximum, potential energy is 0, because there is no height. But in between maximum height to the ground, the energy changes to kinetic to potential, potential to kinetic. But at any point, if you consider, you have to consider the middle. At any point, if you consider, the total energy remains same. The Ke plus Pe is always same in case of freely falling body, right? That I'll show you video later. So that is one kind. At 3 points he considered here. See, at A, at B, at C. First he considered B. Okay, A, B, C, 3 points you can see here. So B is the ground level, C is the middle, A is on top. At 3 points, the total energy always constant. See here, total energy is nothing but at a ground level. The total energy is half mu because initial velocity is u, right? At B. So the point is on the ground, height is equal to 0 because B is ground. Ground, there is no height. No height means potential energy is 0. So what is kinetic energy? Half mv square. But what is V here? Initial velocity u. So we got the total energy as 1 by 2 mu square. The total energy at B. Next case will move. When you move to the next point, C or A, how it is changes you can see. Total energy or check. Maybe it changes from one form to another form, but remains same. Right? At C, kinetic energy is half mv square, right? Where V is the velocity and B is the position of the body. And we know that V square minus U square is equal to 2A's formula. From that, we can get the V square is equal to 2GH, where S is equal to H. Height now we are required to consider. So again, here also you can find the what is the total energy. So at every point, right? At every point, maybe it is repeated. At every point, we can get the total energy as mu square only. It is repeated here. Okay. So this is here you can find for the simple pendulum. Either you can consider free falling body, vertically projected body, or a simple pendulum, that is to and fro motion. Where it is a to and fro, at midpoint, the total energy is equal to a point at A or point at B, or on the way also. So different points you found the what is the total energy, which is equal to potential and kinetic. Okay. So before going for the further explanation, let me show you one video on the law of conservation of energy, right? You see this video, and then we'll go for the further explanation.
In this video, we will learn about energy. What is energy? Energy is defined as the ability to do work, which is when a force is applied to an object and it moves. Energy is divided into two types: potential energy and kinetic energy. Potential energy is the energy stored in an object. Kinetic energy is the energy that a moving object has. How is energy measured? Energy is measured in joules. Potential energy is the energy an object has because of its position relative to some other object. In a slingshot, the potential energy is stored in the object being flung. Forms of potential energy: chemical energy, elastic energy, nuclear energy, and gravitational energy. Chemical energy is energy stored in bonds of atoms and molecules. A battery stores chemical potential energy, which is converted into electrical energy. Elastic energy is potential energy stored as a result of deformation of an elastic object, such as the stretching of a spring or a rubber band. Nuclear energy is the potential energy found inside the nucleus of an atom. Gravitational energy is the potential energy of position or place, like a rock on top of a hill and a girl on top of a slide. Kinetic energy is the energy possessed by an object in motion. Forms of kinetic energy: mechanical energy, thermal energy, light energy, electrical energy, and sound energy. Mechanical energy is the energy of an object due to its motion or position. The sum of an object's kinetic energy and potential energy, like a moving car and a windmill. Electrical energy is caused by moving electrical charges called electrons. Thermal energy is energy that comes from a substance whose molecules and atoms are vibrating faster due to a rise in temperature. Light energy. Radiant energy is electromagnetic energy that travels in transverse waves. Sound energy is the movement of energy through a substance in waves. The law of conservation of energy states that energy cannot be created nor destroyed. However, it can be transformed into one form to
Right. This is the
another.
main statement of the law of
No
conservation of
energy is lost. It is always.
You see here, energy cannot be created nor destroyed. However, it can be transformed. I will explain the meaning. Transformed into one to another. So no energy lost is always conserved. Okay.
Is conserved. Chemical energy from food is converted into mechanical
See,
energy.
we are taking the food.
Chemical
cycling-
energy from batteries is converted to light energy. Electrical energy is converted to heat energy. Chemical energy from fuel is converted into mechanical energy. Light energy from the sun is converted to chemical energy through photosynthesis. Mechanical energy from a moving windmill is converted to electrical energy. Electrical energy is then converted to light energy. So again, energy is the ability to do work. It is divided into two
Right.
types: potential energy
I will
and
come.
kinetic energy.
The clear picture. Right? So there are two types of energies which are further classified into so many forms of energies. Types of energies are two only. One is due to motion, second one is due to position. But in that again, there are various forms are there where we can see on the screen. So potential energy is nothing but energy from the battery, which is called chemical energy, energy of earth, that is gravitational, energy of atom, nuclear, energy of the spring, that is elastic. Kinetic energy, so mechanical energy, energy of muscles, electrical energy, thermal, heat energy, light energy, sound energy, and many more are there. Right? These all are the comes under types and forms of energies, and finally it concludes that energy neither be created nor destroyed. Only it can be changed into the one form to another forms in any case. Right? Whatever the case it may be, it can neither be created nor, just a minute, destroyed. Okay. So for that we have seen there are three examples are given in your material. You can go through all these things, but here only you have to understand whether it is a freely falling body, whether it is a vertically projected body, or it is a to and fro simple pendulum. In all cases, energy is maybe converted into kinetic to potential or potential to kinetic, but the total energy, which is sum of the potential and kinetic energy, is always constant. That proves that there is a law of conservation of energy explaining three cases. Right? Then, so where this energy is going? Where this energy is going? So we are saying that energy is not wasted. But when you are using the petrol, right? When you are taking the 1 liter of petrol, traveling for some distance, the petrol is exhausted. Then where it goes? You are eating the food daily, but by end of the day, you are again become hungry. What happened to the food you ate in the morning? Correct. So when you are using the current, though much current you are using per day or per month, you are getting the bill. Where the electricity is going? Is it destroyed? What happens? Everything. That is comes under transformation of energy. So energy is transformed. There is a transformation. There is no waste of energy. Energy transformation takes place. So transformation means converting to one form to another. One form to another form. So petrol is a heat energy. Heat energy is converting into mechanical, and we are covering some distance. What food you are eating, you are consuming doing the work. When you are doing some work, the entire thing is digested. Some process takes place in stomach. Means it converted into some other form. That is called interconvention of the energies. So in battery, when you take, so see here, interconversion of chemical energy. During the process of burning, a chemical energy changes into heat energy. When you are burning anything, for example, gas, when gas is giving the burning, that gas energy is converted into heat energy or light energy. Gas stove, when you stop, you get the heat as well as light also. When the wood is burned, the chemical energy changes to heat and light energy. In electric drive cells, like our cells or car batteries, the chemical energy changes into electrical. So there is a chemical, it contains electrical and gives out the light, headlights for us or blinkers. How all is possible? Because of the transformation of energy. There are so many examples are there where you can see the energy transformation from one form to another form. See here. Suppose if you take electric fan. So everybody know fan is working. So what happened in fan? Electric energy is converted into mechanical energy. Electric energy is converted into mechanical energy. Okay. Note down the very important one this. Later I will tell some more also. So in case of fan, when you switch on the light, when you switch on the switch, current passes through the fan and that current electric energy is converting into mechanical and makes the fan to rotate. Correct? Then car batteries. In car, we have the batteries, liquid batteries, where chemical energy is converting into electrical energy. Chemical energy is converting into electrical energy, right? The third case, cycle dynamo. You know, cycle, we have dynamo small at the back wheel when you have the light for the cycle, right? So the dynamo also converts the mechanical energy into electrical. When the dynamo touches the tire, you are running the cycle, you are riding the cycle. The tire produces the mechanical energy. With that mechanical energy, is converting into light energy and gives out the light for you. Remember, cycle dynamo is very important. Nowadays, you are not finding, but olden days, they used to have. Microphone. Sound energy is converting into electrical energy. Whatever the sound you are speaking, converting electrical and again reaches to the other person or destination. Loudspeaker. Electric energy is converting into sound energy. Solar cell. Solar, you know, the sun. So solar cell. Solar cell, light energy is converting into electrical. Electric torch. Chemical energy is connected to light energy. Chemical energy to first electrical energy, then light energy. Electric motor we'll use at home for pulling the water. Electric energy is converting into mechanical. With that mechanical energy only, we can raise the water to any height. Suppose if you take a bulb, electrical energy to light energy as well as heat energy also. Geyser, electric energy into heat energy, which makes our water hot. So like that, innumerable number of examples are there in your house only. After going home today, you see around your every room what kind of energy changes takes place, what kind of energy transformations takes place. Because almost all the devices you can find at home. Apart from this, there are other so many devices are there. Like when our oven also, oven, when you pass electricity, convert into heat. Like iron box you may have at home. Iron box converts the electric energy into heat. Right. Refrigerator is there. Fridge. It converts electric energy into light energy and cooling energy. So many things. Whatever the electric appliance you find at home, observe them and make sure that there is a transformation of energy takes place in them. There is no loss of energy. You are paying bill, means you are doing some work with that. We are not wasting that. You are using that electric energy and it's converting into various forms of energies. That change of energy from one form to another form is called transformation of energy. So energy can neither be created nor destroyed, but it transforms from one form to another form. That's all. Right? So these are some examples of devices which converts the energy into another form. So with this, we are almost done with the energy part. So what is energy? What are the types of energies? What are the forms of energies? And what is the law of conservation of energy? And what is the transformation of energy, which can be clearly understood by this table. This table clearly indicates you that how the energy transforms from one form to another, either chemical to electrical, or electrical to heat, or mechanical to some other form, sound energy into electrical energy. So many ways you can see the conversion of the electric energy. Right? Are you sure? Okay. Now the final touching about the power. So everybody know what is the power? The most powerful word, power. Power is nothing but the rate of work done. It's not also work only, but rate. How fast you are doing work, that is important. You may have capacity. So work is different. Energy is capacity of doing work, but whereas power is rate of doing work. If you can do the work fast, you have more power. Rate of doing work. Suppose, simple example I will tell. You and your brother, your younger brother maybe, you are sitting for a food. Your mother prepared so many varieties of food in front of you. It may be veg or non-veg, whatever you like. Right? Both of you are sitting on dining table. You started eating food. I gave you 5 minutes of time. In 5 minutes, who will eat more? Or who will taste more items or more they will eat? I am not testing your energy. You may eat more than your younger brother. But energy point of power point of view, how fast? That's why I kept whenever time is comes into play. See, there is a Olympics also there. Olympic running or athletics or anything, or even in cricket also, you can hit the century. Maybe century you can hit in 200 balls or 100 balls or 50 balls. But how fast you can hit is a very important. Right? See, there are so many centuries made in T20s by Surya Kumar Yadav or Abhishek Sharma. But thing is, who hit the century less number of balls? That is the fastest. Similarly, food also. How fast you can able to eat the food. Within 5 minutes, how much food you ate and your brother ate. That indicates if you eat more food in 5 minutes, your power is more. Means whenever time comes into play, when time comes into play, then that work done is called power. Work by time. So power is nothing but rate of work done. That is work by time. We know work is measured in joule and time is measured in second. So it is measured in joule per second, or the common unit is watt. James Watt, named after a great scientist, James Watt, who invented the steam engine. Steam engine is invented with this power only. Why? Because when he is boiling the water and that vessel is kept with the lid. Lid is kept on that. You can observe at home also. You boil the water and place the lid over the vessel. So whenever water starts boiling, it is convert from boiling stage to steaming. The plate, you can see the plate will jump. Means it is exactly the pressure on the plate. That is the power of steam. With that observation only, steam engine is designed by or invented by James Watt. So this power also named after him. The rate of work done is called power. That is, power is equal to work by time, measured in either joule per second or simply watt. Watt is the practical unit, SI unit of the power. Okay. So not only watt, there are some more units are there, practical units. So definition you can see here anyway, power is the amount of work done per unit time. So SI unit is watt, which is equal to the joule per second, right? Other units power can be also expressed in the other units. Kilowatt hour, I'll explain you. Horsepower, 1 horsepower is nothing but 746 watt. Right? 1 horsepower. You can say horsepower, the vehicles, suppose 2-wheelers or 4-wheelers, their power is measured in horsepower. 7 horsepower, 8 horsepower. You can see when you are buying not only CC, 250cc, 360cc, 100 cc, 110 cc. The engine also measured. The engine power is measured with the horsepower. 1 horsepower is nothing but 746 watt. It is 746 watt is considered as 1 HP, 1 horsepower. Very, very important value here. Then horsepower and erg per second and milliwatt, very important, smallest to pep, milliwatt. Milli means 10 power minus 3 watt. Very small power. Right. Then what is kilowatt hour? It is a practical electrical power. We can measure in the kilowatt hour. So see, that is nothing but 1 unit. We can call na 1 kilowatt hour is nothing but 1 unit. Whenever you get the bill is calculated based on number of units you consumed. Right. That unit is nothing but 1 kilowatt hour. When you conserve 1 kilowatt hour of electricity, then 1 bill, 1 unit is charged. Right. So what is kilowatt hour? So when 1 kilowatt hour is nothing but 1 kilowatt hour. What is kilo? Kilo is nothing but 1000, right? 1000 watt as it is, right? What is hour in seconds? 3600. 60 into 60. So totally 36 into 10 power 5. 2 zeros are there, 3 zeros. So 36 10 power 5. What is there already? What is there? Second is there. 3600 seconds. So watt second. So watt second. Watt is nothing but power. Right. What you can write watt? Watt is nothing but joule by second. Right. As per the power definition. Power is equal to work by time. So from here, watt second is second if you take here. Watt into second is nothing but joule. So you can write it as joule. So 1 kilowatt hour is equal to 36 into 10 power 5 joule of energy. So mostly the largest power of unit which is used to measure the electrical energy is kilowatt hour. What? Kilowatt hour. Right. So kilowatt hour is the largest unit of power used to measure the. Okay. Got it or not? So power is nothing but the rate of work done. The work done per unit time. That is power is equal to work by time. What? Work by time. So work by time. Okay. And work is measured in joule. Time is measured in second. So joule by second or watt, named after watt. And also this power can be measured in other units also. It may be smaller units or larger units. In case of smaller units, the smallest unit of power is milliwatt, and largest one is kilowatt hour, where 1 kilowatt hour is nothing but 36 into 10 power 5 joule. When 36 into 10 power 5 joule of energy is consumed, it is named as 1 kilowatt hour or 1 unit. Right? 1 unit. Okay. So then even horsepower is one of the practical unit of the power, which is generally used in the automobile industry. 1 horsepower is nothing but 746 watt. So this is total information about the, even you can write megawatt, gigawatt. Mega means 10 power 6. Giga means 10 power 9. Okay. All these things are the various forms of measuring the power in the different units. Okay. This is about the entire thing about power. So we learn about all the 3 words in details. So you can see the power, your power you can measure, how much power you have in reading or understanding, presenting in examination. That depends on your power. How much easily grasp what your teacher is teaching. How much you are presenting on paper. How fast. That is time management. Within the time are you presenting or not? Or within the time you are reading or not? You are reading, writing, speaking. Everything depends on your power. So for that, you have to sharpen your brain time to time. Okay. So that is power, power, power. So total with this, we have done with the work, power, energy. We have some worksheets on that. You go through them for the exam, which is on 30th of this month. So next class when you meet, we will continue here, or we can go for the new, we will go for new chapter for this. Okay. So for today's, there is homework, home task is state law of conservation of energy with example. So many examples are given in the table, how the energy is converted. It is neither be created nor destroyed. Okay. It is converted from one form to another form. So note down that question and write answer in your notebook, and take the signature from your teachers and parent. Right. Done. So that's all for today. Thank you, all of you. Have a wonderful day. Thank you.